When wanting to more accurately adjust the timing on something in your scene that's been animated, your greatest level of control will come from using what is called the Curve Editor. To show you how it works, I'll be using a file named Curve Editor. You can find it in the Working Files folder for this chapter. Let's animate the ball moving to a couple of specific locations on the screen. To do that, we'll select the object, then activate the AutoKey command by typing N on our keyboard. Moving to frame 100 on our time slider, let's move the ball into the middle of the bottom circle. We'll then move to frame 200, where we'll use an alternative method to relocating the ball. This time around, I'll use the Align command on the right-hand side of the toolbar. Having the ball selected, I'll now click on the upper right-hand circle, telling Max that I'd now like to align the ball with this shape. In the options, I'll leave both the current object and target object set to pivot, and I'll activate all three X, Y, and Z positions up at the top. Once I've done that, at the bottom of the dialog, I'll choose OK. Let's go ahead and now play back our animation. So we can get a more definitive idea as to the actual speed the ball is going as it travels from one area of the screen to the other, let's activate the object's trajectory display option. You can do that a couple of different ways. Let's right-click on the ball, choosing Object Properties. In the Display Properties category, halfway down on the left-hand side, we'll check Trajectory. Now, another way that we could activate this option is to simply hold down the Alt key and right-click. From the menu on the bottom right side, we'd choose Show Trajectories Toggle. Let's go ahead and turn that back on. Once we've done that, we'll also turn off our Auto key, typing N once again. Okay, what are we looking at here? The white boxes that you see along the red line are your keyframes. In essence, the three locations that you've locked the ball down into place by way of creating a key. The little white dots along the red line in between the keys are your frames. Here's how the trajectory can be read. Any areas along the red path where you see the frames bunching closer together represents a specific area where the ball is moving at a slower pace. You see that coming out of the first key and going into the third. Those transitions are Max's way of automatically building in the traditional principle of easing in and easing out into the ball's movement. In any areas along the trajectory where the frames spread farther apart, like in between the keys, the ball in these areas is moving faster. So what we see in the motion of the ball is that the ball slowly leaves its starting position, maintains a fairly constant speed until it gets to the other end, then slows down again before coming to a stop. Also notice how the ball moves through the second keyframe at the bottom at frame 100 with kind of an arcing transition in and out of the key. Again, this has automatically been programmed in by 3ds Max to create a more realistic motion for the ball. Another traditional principle being applied, this one being the principle of arcing motion or arcing movement, which basically says that when things in the real world move, seldom do they move in straight lines. Machines might move in straight lines, but most real-world objects don't. Now, that doesn't mean that we can't change that motion, and that's typically where the Curve Editor comes into play. Let's say that we want the ball to hit that bottom key and angle upward in a more straight or linear fashion. There's actually a couple of ways that we could make that adjustment. Working down on the timeline, Max offers a handful of predefined controls for adjusting the movement in and out of a key. Let's select the second keyframe located at frame 100. We can do that by simply clicking directly on top of the red box. By now right-clicking on the key, we can open up the Key Info dialog. From the menu, we'll go to the top, choosing Sphere 01 Position. These settings directly control the keyframe on which we clicked. listing the keyframe number, the specific frame where that key is located, and the position of the object's pivot point in 3D space listed by its X, Y, and Z values. You also have two keyframe tangent flyouts, one that controls the movement into the keyframe, while the other controls the movement out of the key. This is where those pre-configured options that I mentioned come into play. If we wanted the ball to move directly into the second key, the location at frame 100 in other words, we could eliminate the arcing movement in that area by changing what is known as a tangent. The tangent needing to be set to linear or straight in other words. Choosing the keyframe option labeled N, I'll make that change. Notice how that now alters the trajectory of the ball going into that key at frame 100. That movement now going straight into that key. If we also wanted that same linear movement on the outside of the key, as the ball sets out traveling upward to the upper right-hand corner, we again could change the tangent, that tangent going to linear. Using the out control in the key info dialog, we'll change it to linear. Playing things back, you'll see that the ball now travels directly down, then directly up, no longer displaying its original arcing nature. If we wanted the ball's motion to go back to the way it originally was, we could simply change our tangents on both sides of the keyframe, returning those tangents to more of an arcing type trajectory. Clicking on the N control, I'll set the option to the lowest icon. This automatically changes both directories, and we're back to more of an arcing motion. The timeline motion controls work fast and easy for small jobs, where maybe you simply need a quick single key change and away you go. But when you want to achieve the highest level of control and the broadest set of options to work with, you'll want to instead use the curve editor. To get there, you've got a couple of different ways that you can go. Up on the pull-down menus, you can choose Graph Editor's Track View Curve Editor, or you can simply right-click on the screen and in the bottom menu, choose Curve Editor. I'll go that way. Okay, the Curve Editor displays what are called function curves. You'll sometimes also hear them referred to as F-curves. An F-curve is essentially a way of displaying the rate and amount of change that is taking place on an object. Each thing that's changing being represented by a curve, and the direction that change is taking place in identified by the color of the curve. The red curve indicates change in the X direction, the green curve represents the Y direction, and the blue curve identifies the Z direction. So just like in using the transformation gizmo, red, green, blue equals X, Y, and Z. Now, I said the curve basically represents the rate of change. You can also think of that as the speed of change. Here's how it works. In areas where the slope of a curve gets steep, whatever is changing quickly. In any areas where the slope starts to level out, not a lot is taking place in that direction or in that particular time frame. In areas where the slope is completely flat, no change is occurring. So in our example, the ball's position in the Z direction, the blue curve, stays constant. There's no change, in other words. And you can see that in the viewport by looking at the sticks on the transformation gizmo. Let me go ahead and zoom out and reposition the scene so you can see that. Now think about it. We didn't move the ball in Z or blue. The only two directions we moved the ball were X and Y, red and green in other words. Back in the curve editor, the little gray squares that you see on the various curves are the keys that we've set at frames 0, 100, and 200. Now, that key info box that we saw down on the timeline is also available on the various keys in the curve editor. At frame 100, let's right-click on the green curve key. With the key info now open, we could certainly make our adjustments directly here. So for an example, let's take the inside of the keyframe back to linear. After seeing the difference that's made to both our trajectory and the slope of the green line moving into that key, we'll change things back to the bottom icon. So the key info controls, whether being used on the timeline or in the curve editor, are handy. But the real power of the curve editor is being able to work interactively directly with the function curve slopes. Remember, it's the slope of the curve that represents the speed of change. By manipulating the handles to both sides of the key, we can dramatically alter both the speed of change and the location of things in the scene. By holding down the Shift key, you can break the handles, being then able to move them independently, and in that, enabling the ball to now move up and down more in a realistic bouncing manner. Holding the Shift key down, I'll move both handles on the green curve upward. And in doing so, when played back, watch the difference that's made. All simply by adjusting the object's function curves. Now, I'm honestly just scratching the surface as to the power and functionality of the curve editor. But that should at least give you an idea of how it works, and hopefully some motivation to start playing around with some of its controls. The better you know the curve editor, the better you'll be able to create believable, lifelike motion in your scenes. I'll go ahead and save the file out as Curve Editor Completed if you'd like to go in for a look.